Okay, so we're going to talk about Taylor polynomials. We're going to start by looking at a GeoGebra file. Open this up. Okay, so this graph looks very much like it's probably a graph of the sine of x. It has a min of -1, a max of 1. It starts at the origin and heads up. It completes one full cycle in 6 point something radians, which is 2 pi. So it looks like sine of x, but if I drag this whole screen over, turns out it is not sine of x. It's a degree 49 polynomial that's got a end behavior that heads up to infinity. So the whole idea today is that we're going to be able to create a polynomial, even if it has to be of the 49th degree, but we're going to be able to create a polynomial that impersonates a random, messy, but differentiable function as closely as possible. So I just showed you a polynomial that impersonates sine of x. Okay, so let's see if we can build one of these polynomials for a function f of x equals e to the 2x. We're not going to use any magic formulas from chapter 10. Those will come later in the activities of this lesson. So P2 is going to be a degree 2 polynomial that we want to approximate or impersonate f of x equals e to the 2x. So it's a degree 2 polynomial, which means it has the form a0 plus a1x plus a2x squared. Or you could use a, b, and c, but in the case of a degree 49 polynomial, we would have run out of letters. So our standard notation is to just call them all a, but put a subscript on them. Okay, so we're going to start by computing f of 0, f prime of 0, and f double prime of 0. And in order to be able to plug 0 into something, you need a formula. So I'm going to start with f of x, which is e to the 2x, and f prime of x, which is going to be 2e to the 2x, and f double prime of x, which is 4e to the 2x. And then I'm going to plug 0 into all of these. F of 0, e to the 0 is 1. F prime of 0 is 2 times 1, which is 2. And f double prime of 0 is 4 times 1, which is 4. So I know really well what the behavior of f is at 0. I know the y value. I know the slope of the tangent line. I know the concavity, right? So I know f of 0, f prime of 0, f double prime of 0. So I know a lot of stuff about f at 0. I want P2 to impersonate f. So I want it to have all this same behavior at 0 that f has. So I'm going to calculate p of 0, p prime of 0, and p double prime of 0. So p2 of x was a0 plus a1x plus a2x squared. p2 prime of x, the derivative of p2, well, the derivative of a0 is 0 because a0 is just a constant. And then the derivative of a1x is a1. And the derivative of a2x squared, I just do the power rule and I get 2a2x. And then p double prime of x is going to be 2a2. Plug 0 into each of these, and I get a0. P2 prime of 0 is a1, and P2 double prime of 0 is 2a2. Because P2 double prime of x is always 2a2, doesn't matter what x is. So at 0, it's 2a2. Okay, part C says, what do the values of a0, a1, and a2 need to be for f and P2 to have the same output and the same first and second derivatives at 0? If P2 of x is going to impersonate f, we want them to have, when we're near 0, then we want them to have the same y value, the same first derivative, and the same second derivative at 0. So I need to set up some equations. I need f of 0 to equal p of 0. I need f prime of 0 to equal p prime of 0. and I need f double prime of 0 to equal p double prime of 0. So I'm going to set the pink equal to the pink, the green to the green, and the purple to the purple. So f of 0 has to equal p2 of 0. F prime of 0 has to equal p2 prime of 0. And f double prime of 0 has to equal p2 double prime of 0. So I'm going to plug in here. F of 0 was 1. P2 of 0 was a 0. Just replacing f of 0 was 1 and p2 of 0 is a 0. Okay, for my next equation, f prime of 0 is 2 and p prime of 0 is a1. So this 2 has to equal a1. And then for the last equation, f double prime of 0 was 4 and p double prime of 0 is 2a2. And then I'm going to solve this to get a2. I get a2 is 2. So I now know what the 3 unknown coefficients are in P2, but the final answer is to write out P2 of x, which was a0 plus a1x plus a2x squared. My goal was to find out what a0, a1, and a2 should be in this formula, and now I know what they are. So my final answer is the formula, but replacing a0, a1, and a2 with numbers. So I'm going to have 1 plus 2x plus 2x squared.